In this video, I'm going to talk about domain and range of a function. And domain and range really just describe the acceptable numbers, values that you can plug into equations or get out of equations for output, that makes sense. Sometimes mathematically, there are certain equations that, might have, there might be issues in maybe dividing by zero, for instance. So say maybe you had a function like f of x equals 3 divided by x. And if you think about what's going on here, think about, values that numbers you could plug in for x. Like if x was 2, 3 divided by 2, that's okay. You can do that. But if x is 0, if you were to do 3 divided by 0, that would be a problem because that's undefined. So, we would say, for instance, in that case, the domain is all values of x, but x can't be 0. So it's really just describing the types of numbers that you're, allowed to put in, so to speak, or that are acceptable values to plug in that don't cause any issues. And I would say a lot of functions, there aren't any issues. You can plug any number you want in, but, sometimes like this function right here, 3 divided by x, you do have some issues. So anyway, so let's just back up and talk about each individually first. So the domain of a function is set of all values of the independent variable x that result in a real number of values for y. So basically we're looking for numbers that you can plug in for x that, won't cause an issue basically. And the range of a function is the set of all possible y values. And so when we do application problems, so those are like real world problems, some values don't make sense for the situation, even when they do make sense for the equation. So this revised domain and range are called the plausible domain and range. And really that just means the domain and range that makes sense for the problem. So for example, I'm going to use the equation that we looked at in the last video, and it was d distance equals negative 68 times time, t, plus 323. And this function, or this equation, relates the distance that someone is from home and the time in hours that they have been traveling, okay? And so if we look at this equation and ask ourselves, okay, so the domain, that's the x, or the independent variable, so that would be the t in this case. So the domain, if we look at the equation, we could say, oh, well, t could be anything because you can multiply any number you want by negative 68 and add 323 and not have an issue. Like you could plug that into a calculator. You could do negative 68 times 1,000. Doesn't matter what number you plug in. You're never going to get an error on your calculator. Any number you can think of would work. So the domain, we say, is all real numbers. And the symbol for that is this R with 2 lines. So we can plug anything in. And then if we think about the range, so that would be the d variable or the distance. So the range in this case. So what types of distances could we, or results could we get by plugging in values for t? Well, we could get any result. I mean, there really isn't any restrictions there. You could plug in infinitely many numbers for t, and so get infinitely many numbers for d. And so the range is also all real numbers. But then when we look at the real world situation, it starts to change a little bit because when we think of distance being distance away from home, there are numbers that, make sense for this situation, and there are numbers that don't make sense for this situation. So even though we say the domain is all real numbers, when we think about time, we would never want time to be negative. So in the real world situation, the plausible domain would be, well, we want time to be greater than 0 because it doesn't make sense for time to be negative. And then in terms of distance away from home, we would probably not want that to be negative either. It wouldn't make sense to say, Susie is negative 300 miles away from home. So, so we can look at it from both ways, mathematically and then just, real world situation, what makes sense. So let's look at example 1. So we're going to consider the function h of t equals 100 minus 6t squared. So mathematically, so we're just looking at the equation right now, what values can be plugged in for t that won't cause an issues? So examples of things that might cause issues might be dividing by 0 or taking the square root of a negative number. Those are things like if I, for instance, I'll do it again, if we do 3 divided by 0 in my calculator, so you get an error. If I try to take the square root of a negative number, so like square root of negative 3 then I get an error. So we want to ask ourselves, is there anything that I could plug into this equation that would produce an error in my calculator? And the answer is no, because this equation, you're just doing 100 minus 6 times any number squared. There's no restrictions there. So all values of t are okay. We could also say all real numbers, or just write the symbol r there, all real numbers. And then if t equals time in seconds, what are some value of t that definitely won't make sense for the situation? So now we're thinking of it beyond the mathematical reasonability, and we're just asking ourselves, okay, what makes sense in terms of time? Well, any positive value for time makes sense. Like if t equals 5, that means 5 seconds, so that makes sense. But it doesn't make sense like if t equals -3, saying -3 seconds, that doesn't make sense. So we want positive values. So negative time values doesn't make sense. Okay, and so if we study the graph and the equation in more detail, we could even delve further. So I'm going to show you the graph using this website called Desmos. So I'm just at desmos.com. And when you first get here, this is what it'll look like. And you just have to click on Graphing Calculator. And this is nice because it's a free website. And all you have to do to graph an equation is you just come up here. And I'm going to, let me just move this up so you can see that little keyboard at the bottom. You just click on the keyboard, and then I'm going to just type in the equation. Now, in this case, I'm not going to write h of t because I don't have those letters. I only have y or x. So I'm going to just write y equals, and then I'm going to write 100 minus 6, and then it'd be x squared, which I can write a squared. Oh, and you know what? Let me go back. That was not right. We want an x squared there. So we're going to delete that, and we're going to do minus 6, and then I'm going to click on the x and then the squared key. And then I'm going to erase this too. Okay, there we go. So we got y equals 100 minus 6t squared. And so we have this graph here, and what we can do, I'm just going to zoom out a little bit so we can see it a little bit more clearly. And so we said before that the domain, so mathematically the domain is all real numbers, so that's any x can be plugged into the equation, and they won't cause any issues. We haven't really talked about range though for this problem. So the range is acceptable y values. So one thing that you can do is you can kind of look at the graph, and you can start at the top where you see the 100, and you can kind of travel down the y-axis and ask, are there any y values that are not going to be plotted on this graph? And so if you notice, if we start at 100, you see the graph, that red line being shown less than 100, but you don't see any graph above the 100. So what this shows us is that the range, okay, acceptable y values, is going to be all numbers that are less than 100. So if we go back to our notes, we can write here, so we have, so this right here, all real numbers, this is our domain. And then for our range, we can write it in words, and I'm going to also show you how to write it in set builder notation. So in words, we can say all numbers that are going to be less than or equal to 100, or I could have written that out in words. And then sometimes in homework, you might be asked to write the range in set builder notation. So the way that you would do that is you always start with curly brackets. And if it's range, you put a y and then a vertical line. And then whatever comes next, this is where you describe what y can be. So if y has to be less than or equal to 100, then you say y is less than or equal to 100, and that's how you write the range. Since the domain is all real numbers, you don't even have to write that in set builder notation. You can just do that fancy little r, and that means all real numbers. Now, if you had a domain, just to show you real quick, so let's say, and this is just an example, this does not have to do with our example here, but let's say you had a domain where x had to be greater than 2. The way you would write that using set builder notation is curly brackets and x, vertical line, x is greater than 2. So you can see for domain, if you have to use set builder notation, you're just going to use an x instead of a y like we did for range. Okay, so let's look at the next example. Okay, so in this example, we're going to look at this situation where we're looking at an equation, this equation right here, and it represents an individual's blood alcohol concentration X hours after a peak level of 0.13. So what that means is, let's say a person has a blood alcohol level of 0.13. That blood alcohol level, so they, drank alcohol, they have a blood alcohol level of 0.13, and then as time goes by, that blood alcohol level is going to go down because that alcohol is going to leave their system. So this equation models, what that blood alcohol content looks like after so many hours of it being, of time going by. So for part A, whereas what is the mathematical domain of this equation? So mathematical means like, what are the acceptable values that we could plug in? Or are there any numbers that would cause issues? And if we look at this equation, we don't have any dividing, so it's not possible to divide by 0, which always causes an issue. We don't have square roots, so those are things to look for that would cause issues. So in this case, we can plug any number we want in. We're just multiplying by negative 0.015, and then we're adding 0.13. So there aren't any, mathematical restrictions for doing that. So in this case, we're going to say all real numbers, or we can just write that fancy R. So all real numbers, which just means any number that, you can think of, negative, positive, decimal, it doesn't matter. And then for B, what is the mathematical range? So range refers to Y. So mathematical domain, that was X. Range refers to Y. And so here, we're considering, are there any y values that we might not see on this, function if we were to graph it, or are there any y values that we would never get as an output by plugging in, whatever values we can for x. And so you can think about it mathematically, looking at this equation, I don't see any problems or any issues that might come into play, restricting the values that you could get for y. The other thing we could do would be to graph it. So let's look at the graph. So I'm back to Desmos, so I'm just going to write my equation. So I'm just going to put y equals, and then I'm going to put negative 0.015x, and then plus 0.13. And it's worth noting here that I did use the subtraction sign for a negative. And that's different than most calculators will have a negative button. So just wanted to mention that. So if we zoom out here, we can see this line, this blue line. We can also zoom in a little bit. And when we zoom in, we can see this blue line that's similar to, it's the same graph that we have in our notes. I just thought this is a little bit clearer here on Desmos. So we can see this line, and so you can see where it crosses the y-axis, which is right here. That's the y-intercept of 0.13. So that's where, like at time 0, a person's blood alcohol level starts at 0.13, and then you can see as time goes on, their blood alcohol, so the x variable, the first coordinate is time, the second coordinate is their blood alcohol level. So watch that second coordinate, and you see that number decreasing, decreasing, decreasing. It goes down, 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 and eventually we'll get to 0. And so we're trying to ask ourselves for range, are there any y values that could never be we could never get as an output. So check out the y, the 0.083 right now, and I'm going to move it to the left, and they keep going up, 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 up. Those get bigger and bigger, bigger. If I go in this direction to the right, they get smaller, smaller, smaller. Are they ever going to stop? Well, let's zoom out. Do we ever see this line stopping at any point? And the answer is no. You can zoom out infinitely many times, and that line keeps going. So the y values are going to continue to get bigger and bigger and bigger, or smaller and smaller and smaller, depending on what direction you're heading. And so the mathematical range for this one is also going to be all real numbers. Okay, so now we're going to be asked a different question. So what is the plausible domain? So what x's make sense for the situation? So remember that x is time, so x equals time, in hours. So just ask yourself what times make sense. And what makes sense is we want to look at when time starts, so when x is 0, we don't want to look at any negative time because that doesn't make sense. And then we want to look at the end time. So we'll call it the end when the blood alcohol is 0. So when the blood alcohol level is 0, because beyond then we don't really care. So we can do two things to find that out. We can look at the graph and we can see where it crosses the x-axis, which it looks like it's somewhere between maybe 8 and 9 or 8 and 10. I can pull up, we can find the x-intercept algebraically by plugging in 0 for y and solving for x, or I can just go to Desmos and I can use my cursor to kind of move along until that y value is 0. And you can see that at 8.667, we have a y value of 0. So at time 8.667, so a little bit more than 8 hours, almost to 9 hours, we have a blood alcohol level of 0. So it makes sense to look at time from 0 to 8.67 hours. Okay, so how would I write that using set builder notation? Well, I'd do my curly brackets and I'd say all values of x such that x needs to be greater than or equal to 0 and less than or equal to 8.67. Beyond that range, it doesn't really make sense to use this equation. And then range, what's the plausible range? Well, we kind of have to think about range. That's our y, which is our blood alcohol level, and we know that this blood alcohol level starts at 0.13, so it would make sense to start there, and then it makes sense to consider blood alcohol level from there all the way to 0, because it's never going to be negative. It doesn't make sense to have a negative blood alcohol level. So the range is going to be all values of y such that y is greater than or equal to 0.13 and it's less than or equal to 0. So that's how you would write the range using set builder notation.